Hello and welcome back, everybody. Today in geometry, we are going into a new chapter, which will be on translation, reflection, and I guess dilation. So basically, kind of like taking all of the geometrical figures that we've learned over the past year or so, and moving them around, stretching them out, and all that kind of fun stuff to see what the image is going to be like. Okay, so to begin with, we're going to start with a very simple type of translation, which is called reflection. So that's what this section is about. So let me go ahead and give you a formal definition for this. And actually, before we doing that, prior to this, keep in mind that you're supposed to know the terminology isometry, which basically means that distance is preserved. So that's pretty much the only thing that we have to work off of. All right, so here it is. So the definition is that whenever you're talking about reflection, a reflection off a line is called, whenever you have a reflection of any set of points and your reflection is off a line, we'll go ahead and say that line is L. It maps any point P to that point, what is known as P prime, on the opposite side such that the following is true. The first condition is that P prime, this line segment, is perpendicular to that line L of the reflection, such that it is going to be also the perpendicular bisector. In addition to that, if point P is going to be on line L, then that means that P prime, the image that is supposed to be, is going to be the same thing as the original point. So that definitely sounds like a lot of words, but a little hard to understand. So let's go ahead and draw a picture so you can see and understand what we're talking about. Let's say that here is going to be some point P, and then there is going to be then line L over here. So what I'm going to do is I'm going to go ahead and take point P and reflect it off of line L. So as a result, if you can think of like L as kind of like a little mirror, or it's kind of like, like a mirror, like a middle, then it's going to be the case where P is going to be reflected off that line, off of a perpendicular, and then it goes off onto the other side, often to such that it is going to be, I guess, like equidistant to line L. So right here, that is going to be where P prime is going to be. Now, the two conditions that we're talking about over there, well, that's exactly what's happening over here. You'll note that P prime, the line segment right there, is basically being perpendicular bisected by that line L, because these two right here are going to be congruent to each other. So again, think of line L is going to be kind of like a mirror, and then the further you step back from the mirror, or the further your image is from the mirror, it looks like. So that's the idea of reflection then. Whereas, like, say, if you have a point A over here, then you can go ahead and draw a line segment that is perpendicular to L all the way to the opposite side over here, and this A prime, that would then be the image as a result of reflecting off line L then. Okay, so the last part of it, the second part, is that they're saying, hey, what if your point is actually going to be on line L then? What if your point is not on the one side, but it's going to be on that line segment? So then in this case, if you reflect something off the line segment, then it's not going to go anywhere because there is no distance between the point and the line then. So that's really all it is for the last part. Let's see, a couple more things over here. Is that P, that is what is known as a pre-image, meaning like, the point that you have before you reflect it, we call that a pre-image. That's just, kind of like a fancy name for it. But whereas P prime, the point that you're supposed to get after you reflect it, that is what is known as the image then. So if you can think of it as like, pre-image is kind of like the input, and then the image is kind of like an output. So pre-image is like the X value, and then the image is like the Y value that you get when you put it into a function. All right, so that's the idea behind a reflection. So let's go ahead and utilize this to see how it works out. And by the way, before we do so, we should note that according to the last section right here, a reflection is going to be an isometry. And what that means is if you have a set of points that you are going to reflect off this line L, then the result is that those set of points, the length of it, the size of it, everything like that is going to be preserved. So for example, let's say that I have a circle over here on the left hand side. Those are going to be that's going to be my set of point. And if I take that circle and reflect it about line L, so the best way to imagine is that if this entire piece of paper is being folded against line L, then that means the circle is going to be on the opposite side as its image then. So right there, that's going to be the image, whereas this is going to be, whereas this guy is going to be the pre-image. Note that the circle does not change in size or anything like that. So because the distance is going to be stay the same, or the shape is going to be preserved, therefore it is an isometry. So that's what we mean by isometry then. Same as, like, say if you take a line segment over here, and then if you take that line segment and reflect it about line L, the result is that you'll have a line segment on the opposite side, which be the case where they are still going to be congruent and nothing's going to be stretched out. Okay. All right, so now let's go ahead and go into the example to see how this actually works out. So note over here, what's happening is I'm going to give you 3 points, A, B, and C, which you can see on the right-hand side on these axes. And I want to do the following rotation according to what we have. Now, the notation down there represents the, sorry, not the rotation, the expression that I have underneath, that is supposed to be the expression for a reflection. So wherever you see R like this, that means reflect. And then this little subscript over here, that is going to be the line that you are going to reflect it about. And this point over here is going to be my pre-image. And then the result over here, that is going to be my image as a result. So in this first problem over here, part A, we're basically saying, hey, take point A, which is located over here. Take here, point A. And I'm going to reflect it about the x-axis. Where is the result going to be then? So if you can kind of like see where the x-axis is located and A, where A is located, the best thing is, okay, if you take A and then you fold the entire paper about the x-axis, where will the result be? Well, the result will be probably somewhere over here then. So this is where going to be the after image is going to be, A prime. So in terms of what that coordinate is, we can just go ahead and write it, which looks like to me it's going to be 6 because the x value looks like it's going to be saved, whereas the y value looks like it's going to be changed to a -2 because now you're in quadrant 4. So that's the answer. It's as simple as that, okay? The next one, well, let's go ahead and try the same thing then. This time around, what I want to do is I want to take point C over here. Oops, gotta use the wrong pen. So let me go ahead and change that a little bit. Okay, so I want to go ahead and take point C. And I am going to reflect it about the y-axis. Okay, so I'm going to take point C and reflect it about the y-axis. I want to know where the result is. So you can see that point C is located right here, and the y-axis is located right here. So if you fold your paper that it's on and you fold it about the y-axis, the result is that C is going to be on the opposite side, such that it is equal distance to the y-axis. So then this point over here, that is going to be your after image, which we can call C prime if you want. But more importantly, the coordinate that we want from there, it looks like it's going to be -2, 2 then. So that is going to be my answer. So you can kind of see that the best way to probably do this is literally just draw it on the x-axis and the y-axis, the xy axis basically, just so you can see where everything is going to be then. So then that way you don't have to like guess and check or just think about it numerically, right? All right, so let's go ahead and clear some of this stuff out, and let's go ahead and see if we can solve for the other stuff. This time around, I'm going to go ahead and take point B over here. Okay, so we're looking at part C right here. We're taking point B. Okay, so there's point B, and we're going to reflect it about the line y is equal to 2. So this time it's not an axis that I'm reflecting it about, but you know, it's still the same idea. So first, I'm going to locate that line y is equal to 2, which is literally located right here. So that's going to be my line then as a result. Okay, so here's y is equal to 2. If you take point B and reflect it about that line, then it definitely looks like it's going to go down this way. Let's see. It goes down 3 units in order to get to the line. And then probably that means that it goes down 3 more units in order to go across it and reflect it. So then that means that this new point we'll go ahead and call B prime. Looks like it's going to be -1 for the x value. And the y value, it looks like you went down by 6. So that means this is going to be -1 then. So that's your answer, -1, -1. Okay. All right. This one, part D, is a little bit difficult, a little bit more difficult. I wouldn't say really, really difficult. This time, what I would like to do is reflect about the line y is equal to x. So it's no longer a horizontal line or a vertical line, but I want to reflect it about, let's see, a diagonal line in this case, okay? So let's see, in this problem, it says take point A. So here, once again, we have point A, and we are reflecting it about the line y is equal to x. So y is equal to x. Let me just go ahead and draw that out just to make things a little bit easier. So here is that line y is equal to x. And if you remember, the best way to think about this is that line right there, y is equal to x, is supposed to be the perpendicular bisector of the segment that you are going to create between the pre-image and the after image. So the way I can think about it is that, oh, okay, so for this line y is equal to x, the slope is equal to 1. So therefore, the slope of the line that I'm supposed to draw is supposed to be the negative reciprocal, which is going to be -1. So that means I'm going to draw something like this over here, okay? So that these two are going to be perpendicular to each other. Note once again, y is equal to x, the slope is 1, so therefore its perpendicular is going to have a slope of -1. So from there, I'm going to go ahead and draw an amount of distance that looks like it's going to show me where A prime is going to be after the after image. So it looks like I went diagonally up by kind of like 2 units, so I'm going to go up diagonally by 2 units. So it looks like over here, that's going to be my point. That is my after image, so that looks like it's going to be the coordinate 2, comma 6 then, okay? So again, there's really no way for you to do this algebraically. Well, I mean, technically there is a way, but I think it's easier just to go ahead and draw everything out, okay? All right, finally for the last part, this one is just kind of a little bit of reverse engineering. So what I want to do in the last problem is I want to find out what is my line of reflection so that C becomes point A. I want to know what my line of reflection is so that C becomes point A. So let me just go ahead and erase all of this stuff over here, okay? So I want to know if I take point C and I want to know reflected about what line, then the result will be A then. So here, maybe what we can do is draw CA as kind of like that segment that we were talking about, like PP prime. And then the best thing is then draw the perpendicular bisector. So that means it's going to be this guy over here. So right in the middle, I do believe that when x is equal to 4, that's going to be the line then, because that's the midpoint, the perpendicular bisector of CA then. So that means it's x is equal to 4. All right, well, there you go. Thank you so much for watching. I will see you guys next time. Have a good one. Bye-bye.